Hi folks. So today we are going to be going over what happens when we adjust our quadratic functions. So today in class we went over a little bit about x squared, but now what happens when you do something to it after you square the input? So it's a build off of our original function or our parent function, our OG function. We're just gonna do something to it after we've squared it. So our original function, just like we did in class, -3 squared is 9, -2 squared is 4, -1, 1, 0, 1, 4, 9. I got these numbers just by squaring them. But if I want to do the f of x function, I'm going to take x squared, these numbers, and I'm going to subtract 2. Before I do that, let me put in my OG, my original. So if this is the one that we need to do really fast, let's see how quick we can do it. I like to start at the vertex 0, 0. It goes over 1, up 1, boom, boom. Over 2, up 4. Over 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And since it's a parabola, everything on this side is going to have a twin over here. So this one has the same height. Over 2, same height. Over 3, same height. Let's draw in our original, because this is what we're going to be comparing it to for all these graphs today. After you square it, it wants you to -2. So we are going to take x squared and take 2 away from it. That becomes 7, -2 becomes 2, -2 becomes -1, -2, -1, 2, and 7. So let's plot these ones. I'm going to start at the vertex again at 0, -2. 1, -1. 2, 2. 3, 7. 1, 2, 3, 4, 5, 6, 7. And again, anything that's on this side is going to have a twin over here. All right, so let's figure out what happened. What happened to the original graph? Well, it was right here. And it looks like it just moved downward. How much? So it moved down. I'm going to say shifted down. How many units? Well, each and every one of these points went downward. It looks like they went down too. And that makes sense because our function subtracted 2. Okay, let's move forward. What happens when we add to it? Well, let's do our original function. -3 squared is 9, -2 squared is 4, and it keeps going. Let's draw in our original function because we're really good at that. This one's graph is a little bit different because the boxes are a little bit tinier. We do it the same way. Over 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 3 away. I'm going to do 3 away over here as well. This is our original function. Now let's see what happens when we take that and add 4. This becomes 13. That becomes 5. Okay, so our new origin, or our new vertex, is 0, 4. 1, 2, 3, 4. 1, 5, negative 1, 5. 2, 8, negative 2, 8. And then it goes 3, 13, 9, 10, 11, 12, 13. So what happened to the original graph? All the points seem to move up. So shift it up. It looks like it went up 1, 2, 3, 4 units. And that makes sense because it was adding 4. All right, so what does this h do? What happens when you add or subtract some number called h? Well, if it's adding h, it looks like you're going to move up whatever h is in units. If it's minus h, you're going to move down whatever h is units. So this first page was all about what we call the vertical shift. So on the side, will you guys write vertical shift? All right, let's do the next page. Very similar. We're going to start with our parent function, which we know is 9, 4, 1, 0, 1, 4, 9. These become really, really fast because we do it so much. 5, 6, 7, 8, 9. Now, this one's a little bit different because we're not subtracting 3 from x squared. We're subtracting 3 from x, and then we're squaring. So in this case, it would have been negative 3 minus 3 squared. That gives me negative 6, and negative 6 squared is 36. Do the next one. Negative 2 minus 3 gives me negative 5. Negative 5 squared, 25. Negative 1 minus 3. This gives me negative 4 squared, which is 16. 0 minus 3 squared gives me negative 3 times negative 3 is 9. 1 minus 3 gives me negative 2. Negative 2 squared is 4. And then negative 2 minus 3 squared gives me negative 1 squared, which is 1. And finally, 3 minus 3 gives me 0 squared, which is 0. So let's start plotting these points. I've got a 3, 0. 1, 2, 3. I have a 2, 1. 1, 4. 1, 2, 3, 4. 0, 9. 1, 2, 3, 4, 5, 6, 7, 8. About right there. Now it looks like it's curving down. It's going to bounce back up. So let's squeeze in what happens at 4. 4 minus 3 squared gives me 1 squared, which is 1. And then it bounces back up again. So I've got my new parabola starting to bounce up, and it's symmetric, so both sides have to be the same. We can just copy these points over. All right, take a look at your graphs. How did the parent function change position? It looks like it moved to the right. How many units? 1, 2, 3. So all of our points from here to here, here to here, they all shifted the same amount to the right. So this one would be shifted right 3 units. And that makes sense because that's what happened in our equations, subtracting 3. It seems like subtracting 3 would move to the left, but in this case, it's going to move to the right. It's a little bit opposite from what you would think. All right, next one. Let's put in our parent function. Negative 3 squared is 9, negative 2 squared is 4, and so on. Let's plot our OG function. Four, 5, 6, 7, 8, 9. If I'm going too quick, just pause the video and catch up with me. Or rewind it and rewatch what I was saying. All right. There is our original function. This time we're going to be adding 2. So if I've got negative 3 plus 2 squared, I get negative 1 squared, which is 1. Negative 2 plus 2 squared, which is 0 squared, I get 0. Negative 1 plus 2 is 1, so 1 squared is 1. 0 plus 2 squared gives me 4. 1 plus 2 squared gives me 9. Now some of these are not going to fit on my graph, like this 16 and that 25 are too big. So let's just put in what we can fit. Negative 3, 1. 1, 2, 3, 1. Negative 2, 0. Negative 1, 1. 0 goes to 4. And 1 goes to 9. 5, 6, 7, 8, 9. So right now my parabola is looking like this. It's going to have a mirror over here because it's starting to pick up on this side. Boom. So what happened to the original graph? How did the yellow become the red? Well, it looks like everything just moved over. By everything, I mean all the points. They all moved over to the left. Shifted. Left, looks like 1, 2 units. So in our first situation, we moved to the right. In the second one, we moved to the left. So this new value k, what does that do to the function? Well, when we were adding k, like in this example, we were shifting to the left. K units. So whatever k is, it's telling you to move to the left that many times. If we were minusing k, we are shifting right. K units. Whatever those might be. And that's it. In class tomorrow, get ready to start going in and out of these two types of equations, the x plus or minus k squared, and then the x squared plus or minus h. Notice that the h has nothing to do with the x squared. You have to do the x squared first, and then you deal with the h. But the k directly affects your input, and after you do that, then you square it. So that's the difference between these two equations. All right, see you in class tomorrow. Bye, y'all.